Great. Okay.
It won't come on 'cause
Yeah, thank you, Rosemary, for organising. So yeah, for those who don't know me, I'm Becca. I have just finished a 4-year project on the integrated management of the bean seed fly. Submitted it at Christmas time. So it was a bit of a whirlwind with Christmas, and I started my job 6 days later. So I've hopefully made this as useful as possible today, but I will, please ask questions at the end. I've also put my contact details at the end if anyone wants to ask further questions there too. Ooh. There we go. Can you see that as well, Rosemary? Sorry. Yeah, okay, great.
Yes,
so,
sorry, yes.
Thank you. So I'm going to take you through well, and I'm just going to introduce the bean seed fly to begin with. I'm very aware that as you're here, you've probably experienced it yourself, so it doesn't need much of an introduction, but I'll go through it for anybody who's unaware. I'll then take you through the aim and then the objectives of the PhD. But mainly I'm going to focus on the findings and then some final conclusions and what is the future of bean seed fly research. So yeah, I'm very aware that probably most of you have maybe experienced bean seed fly damage, but so I'm just going to go through it briefly. It's a complex of 2 species of fly, the Delia platura, Delia florilega. So there's 2 pictures there. They're hard to that you can't distinguish them without a microscope, but they both do the same damage really. And it's a problem because when it's in its maggot form or larvae state, that's the state that it eats loads. It is going to have a go at any sort of germinating seed, but most of the damage is reported on beans, peas and onions in the UK, but it's generalist, so it'll have a go at anything. So there's some symptoms on the right there. You've got sort of plant death in onion, top left. Top right, you've got damage in beans, and it's predominantly getting worse as you go to the right there. So you have a healthy bean plant on the left. Then you've got sort of some lesions in the leaves, all the way through to something called bald-headedness, which is lack of development from the cotyledons, and that's the second plant from the right. And then in the bottom photo there, you've got patchiness in emergence, which is sort of a symptom at the field level. And the problem that growers have been facing is that there haven't been any effective insecticides for the insect in the UK. So an alternative strategy that doesn't rely on the sole use of chemicals is required. So that's where the project came in, and that was why it was funded. It was to contribute towards an integrated pest management strategy to reduce crop and economic losses caused by the bean seed fly in the UK. And I didn't say at the beginning, but the project was half funded by the University of Warwick, and then I think it's a quarter AHDB, quarter PGRO. And then we split it into 4 objectives, focusing on preventing damage, monitoring bean seed fly damage, investigating the biology of the fly, and then forecasting or predicting its activity. But for the purpose of the presentation today, I'm just going to focus on objectives 1, 2 and 4, because the findings from these experiments were hopefully going to be of use to you guys. So the first objective was to assess cultural and interference strategies on reducing damage, identify effective trapping methods for monitoring the fly, and then the 4th one was to create and validate a model to forecast the spring activity of bean seed fly. And we came about these objectives after an initial meeting we had back in 2019 before the pandemic, where we got sort of advice from potentially some people that were in this webinar today. So I've sort of arranged the presentation around each objective, and under each objective I'm going to just state what we knew already. Then I'll take you through the questions that we asked, the sort of brief methods to just contextualise the findings, and then what these mean. So objective 1 was around cultivating and covering the crop as a way of preventing damage, and we were interested in this because our findings could hopefully prevent or reduce larval feeding on the crop. So what did we already know? Well, the literature had said that bean seed fly are stimulated to lay their eggs in areas of high organic matter, and then when they hatch, they'll start feeding on what is surrounding them in the soil. For example, recently cultivated soils could potentially sort of attract bean seed fly due to the volatiles or the chemicals released when you cultivate it. And then the second thing we wanted to investigate was covering the crop, because this could be a physical barrier, could stop the flies from actually getting to the soil surface to lay eggs. So we had 2 questions. Question number 1 was, does cultivation affect the number of bean seed fly caught in water traps? So we were just looking at, is the cultivation bringing the flies to the area? And 2 was more of an applied way of maybe reducing damage, was, can the timing of cultivating and covering newly sown seeds in relation to the timing of sowing the crop reduce bean seed fly damage? So I'm going to take you through question number 1 first. Oops. It keeps freezing slightly, so I'm just going to leave it a moment. There we go. So the methods of the first question, which was, does cultivation affect the number of bean seed fly caught in water traps? I've just kind of done a visualization of what we did. It was quite simple. We just had a bed and it wasn't cultivated to begin with. And we put some traps in it. And on day 1, for example, we took counts. Day 2, we took counts. Day 3, we took counts. We then cultivated. Day 4, we took counts of bean seed fly, 5, 6, etc. And then we compared all of this to a bed that was not cultivated at all. So what did we find? So does cultivation affect the number of bean seed fly caught in water traps? And the answer was yes, but only during those first 24 hours after cultivation. So when comparing the bed that was not cultivated to the bed that was cultivated, within the first 24 hours after cultivating, we found a significant increase in numbers of bean seed fly caught in the traps in the bed that was cultivated. And we've got some graphs here if you're interested in seeing the actual results, but you can just take my word for it as well. But what we've got in these graphs is that there's graphs within the graphs. The box plot, as we call them, on the left is taken 24 hours after cultivation. All of it's taken 24 hours after cultivation. Box plot, the box on the left within each graph is showing a higher count of bean seed fly than the box plot in the right, which is generally lower throughout. So that was the results of that experiment. The next experiment was asking, can the timing of cultivation and covering newly sown seeds in relation to the timing of sowing reduce bean seed fly damage? So we've got some details of the experiment for the field trials on the left there, but all you mainly need to know is that they were done on vining peas and dwarf French beans. This bit in the middle, which is the table, is showing the treatments. So we had 6 cultivation treatments. So cultivation occurring 21 days prior to sowing the seeds, all the way to day 0, which is cultivating on the day of sowing. On the right, we also have crop covering treatments. So these were all cultivated on the day of sowing, and some plots were not covered. Some plots were covered immediately after sowing, and some plots were covered the day after sowing. And things we measured, so we were measuring the number of emerged plants. For the beans, the number of bulb-headed plants. In peas, we were looking at the number of seeds or plants to contain larvae, or looking at tunnelling within the seed. But unfortunately, the results from the vining peas were inconclusive. We think this was mainly due to the number of bean seed fly in the year of the trial in the trial site was very low. So I haven't decided to show this data today because it was confusing to go through for the thesis. So we're just going to look at the dwarf French beans. So can the timing of cultivating and covering newly sown seeds in relation to the timing of sowing reduce bean seed fly damage in dwarf French beans? And the answer is yes. And the advice that we kind of went with in the conclusion of the thesis was delay cultivation by 14 days in relation to sowing, or if you cannot delay the timing of cultivation, cover the crop with a fine mesh immediately after sowing the seeds if you're cultivating on the day of sowing. So what have I got here? Oh yeah, so this is a graph. This is of the first repeat of the trial on the dwarf French beans, and what you can see is, I think I'm just going to press that button, yeah. So you've got the stars are highlighting where we had increased numbers of plants that were bulb-headed, and that bulb-headed symptom is the lack of development from the cotyledons. And so those that were cultivated on the day of sowing showed an increased number of plants to be bulb-headed compared to the other treatments. And then looking at that graph on the right, the plots that were cultivated on the day of sowing but were not covered or covered one day after sowing showed increased counts of bulb-headed plants compared to those that were covered immediately after sowing. So that's suggesting that's why we're suggesting to cover the crop immediately. But why 14 days? So we did some other measurements, and they were of sort of looking at lesions in the leaves and plants to show no symptoms whatsoever. So this is just a table I've just taken from the thesis. There's no need to really go through it in detail. But yeah, that level is showing plants to show no symptoms, and when we do the stats tests, we do pairwise comparisons. So we're looking at individual treatments. So on the right, we're looking at plants that were not covered but cultivated on the day of sowing, comparing them to cultivation that took place 7 days and 14 days and 21 days prior to sowing, and those were significantly different in the number of plants that showed no symptoms. But when looking at major leaf lesions in the leaves, we saw that the only significant differences were when we were delaying cultivation by 14 days. So that's why, delaying sowing, I mean by 14 days. So that's why we've gone with those 14 days. I think Becky has gone through this in the past in our previous meetings, but similar findings were found by PGRO. Yeah, generally there's a decrease in the number of plants damaged as you increase the timing between sowing and cultivation. So the conclusions conclusions from this project on how to prevent or reduce larval feeding. So we asked, does cultivation affect the number of bee and seed fly caught in traps? Yes. So that's just generally growers should be cautious when sowing seeds during the first 24 hours after cultivation. But this study didn't provide any information on egg laying activity. However, we went a step further and looked at sort of actual damage. We found that yes, we can decrease damage in the crop in dwarf French beans if we delay cultivation or cover immediately after sowing. And so yeah, those were our pieces of advice. Delay by 14 days to reduce the risk of bulb-headedness and major lesions in the leaves. But yeah, we did have low numbers of bean seed fly throughout all the trials, which was potentially affecting the trial, and this potentially affected the trials on vining peas. And I did highlight in the thesis the trade-off between sort of seedbed quality when you delay cultivation and sowing, and then there's the trade-off between the risk of larval damage. So yeah, that is my findings from objective number 1, which I hope are useful to you. Again, it's just freezing again, so there we go. So now we are going on to objective number 2, which is monitoring fly activity. So generally, the idea of this objective was to find effective methods of increasing the selectivity of blue sticky traps to bee and seed fly. So monitoring a species with a trap in a field can inform a grower of when an insect is becoming more abundant on their farm and in their crop. And bee and seed fly can easily be confused with similar species. So this yellow trap in the bottom here, the top row is bee and seed fly, the bottom row is cabbage root fly. They are different in size, but it's very difficult differentiating between them too when you've got a trap with other species of insect on it. Sticky traps seem to catch more bee and seed fly than yellow water traps, and blue sticky traps generally catch a larger ratio of bee and seed fly to cabbage root fly. So that's a good way to sort of help differentiate between cabbage root fly. So, and generally the aim of this, like I said, the aim of this objective was to find a strategy that traps more bee and seed fly than similar species. So the research questions, we had 4 research questions. Number 1 was, can a lure attract more bee and seed fly to a blue sticky trap? And I'll go into details of that lure in a minute. Then we looked at orientation of the sticky trap. So we were looking at curly traps and horizontal traps. And again, we had lures involved in that trial too. We had a trial on trap height, and then a trial on sort of mimicking traps that had lots of insects caught on them, and how selective or how attractive these are to bee and seed fly. So for number 1, does a lure attached to a blue sticky trap affect the number of bee and seed fly caught on the trap? And our results suggested yes. And we found that significantly more bee and seed fly were caught on traps containing a lure as compared to traps with no lure. And the traps contained, I'm going to pronounce this one wrong, 2-phenylethanol and N-valeric acid, which are components of decomposing onion pulp. So that was quite final, so that was good to know. Then we had question number 2, which was looking at the orientation of the trap. So does the orientation of a trap with a lure attached affect the number of bee and seed fly caught on the trap? And yes, we found that significantly more bee and seed fly were caught on traps that were horizontally orientated than curly orientated, and that was when a lure was attached to both of them. So this is just showing our results from this experiment. And so on the left of each inner graph, we've got curly traps. On the right, we have horizontal traps. But one thing to consider was that the traps containing a lure caught more hoverflies than traps not containing a lure. So there's an issue of bycatch of a beneficial there. Question number 3 was, does the height of a blue sticky trap affect the number of bee and seed fly caught on the trap? And we found that yes, significantly more bee and seed fly were caught on traps that were lower to the ground than ones that were higher from the ground. So we had 0.25 meters and 0.5 meters were generally good, and then we had 1 meter and 1.5 meters, which generally caught less. However, these experiments kind of showed varying results, but the stats tests are suggesting that those that are 0.25 and 0.5 meters above the soil surface caught more. But again, we had a few issues with this experiment. More bees and wasps were caught on those that were 0.5 meters above the soil than those 0.25 meters, 1 meter and 1.5 meter above the soil. So another issue of bycatch of a beneficial. And then we also had an issue that lower down traps were more susceptible to hungry birds. And that's just a theory that it was birds, but there were a lot of legs of insects on the traps and no bodies, so assumed it was crows eating them. So that's something to consider as well. Finally, in this selection of experiments, we looked at, does the percentage of a blue sticky trap covered with black card, which is to mimic insects being caught on the trap, affect the number of bee and seed fly caught on the trap? And the answer is yes. The findings suggest that bee and seed fly will be less attracted to traps that have 25% or more of the surface covered by insects. So yeah, some more box plots here. The box plots on the left of these graphs are traps that did not contain any black card on them. They were fresh traps, and they caught more bee and seed fly per 2 centimeters square than those traps that had 25% to 75% covered by black cards. So that's suggesting that you kind of want to be changing traps over as soon as you get more than get 25% covered with insects. So the conclusions and advice for monitoring bee and seed fly. So from these experiments, we suggest that you use blue sticky traps, you use a lure, you position them horizontally, and the lower down traps are potentially more selective to bee and seed fly. We recommend that you monitor the traps probably daily, and change the trap once 25% of the surface is covered, and hopefully this will make your traps more attractive to bee and seed fly than similar species. But yeah, there's an issue with bycatch with this type of trapping, so that's down to a moral judgment and wondering if it's actually having a significant effect on populations. Which, yeah. Anyway, I'll pass them to Rosemary for this bit, which is about smart trapping.
Okay, many thanks, Becca. Some of you, I know I've been working with some of you looking at using smart traps, and some of that was part of an EU project we were in called Smart Protect, that was looking at all sorts of smart approaches to pest and disease management in vegetables. So in Smart Protect, and I say with some of you, we've been looking at monitoring bee and seed fly with smart traps. So smart traps basically have a small camera in them that can take a picture of the trap surface at any time you like, and then beam the image to effectively to a website, and then you can look at your trap surface at any time of the day or night. So there are it's not a perfect system, but it's good because you can inspect your traps every day, and something like bee and seed fly, it's probably quite important to do that. So the issues are, I'm pretty convinced now that because the trap has to be quite close to the camera, that actually it does prevent a proportion of the insects, the bee and seed flies, from reaching the trap. So I guess compared with a freely exposed trap, it's not so effective. We have tried both vertical and horizontal traps in our work. And the other thing, which is why Becca did the experiment with the pieces of black card, is that you do need to be aware that it's great looking at it from the office every day, but it still needs replacing fairly regularly, otherwise the efficiency of the trap goes down. So I'll hand back to you, Becca. Thank you.
Thank you. I've just got, oops, there we go. There's just some partners in that project. I'll go on to the next objective. So the final objective I'm going to talk about is predicting the spring activity of the bee and seed fly. I'm not going to go into too much depth on this one, but I'll just introduce why we were doing this. So I haven't actually got the graph in this presentation, but bee and seed fly emerge in large numbers in the spring after a period of dormancy over winter, and this is termed diapause in the insect world, which is a bit like hibernation. And we know that the similar species cabbage root fly, there's absolutely no activity of bee and seed fly in water traps at Warwick Crop Centre over the winter. However, bee and seed fly were showing low levels of activity in water traps over the winter at Warwick Crop Centre. So it was suggesting that maybe bee and seed fly have a slightly different strategy to cabbage root fly. And then they emerge in large numbers in spring after they sort of all collectively emerge after this period of dormancy. So that's why we did the experiments on the biology of bee and seed fly, because we didn't really know at all about what was happening over the winter, and we needed to know this to be able to effectively predict its emergence in spring. So generally, insects are primarily controlled by, their development is primarily controlled by temperature. So insect forecasts are based on environmental factors such as temperature. And many models use the accumulation of day degrees to predict insect activity. So day degrees are essentially the accumulation of, is a cross between temperature and time. So it looks at the accumulation of temperature units over time. And that's the equation on the left, but you don't need to worry about that. And on the right, we've just got a model that was used to predict another species of fly in the midge in the UK. And so I kind of used the methods used in this study to sort of predict bean seed fly emergence in the spring. And these were taken from water trap counts at Warwick Crop Centre over a period of years. So generally, this model is looking at the accumulation of day degrees from the 15th of November. And the 15th of November was used because some experiments on the overwintering biology of bean seed fly suggested this. And then on the vertical axis, we have the proportion of adult flies to be captured from that first generation of bean seed fly in the spring. So those are all the dots there, and then the lines in the middle are showing the prediction of emergence. And then this line gives an equation, and then from this equation we can pump in our desired proportion of flies to be captured and the predicted accumulated day degrees for when these are going to emerge. So yeah, I think I've just explained that lab experiments suggested the 15th of November, and then this is just showing the accumulated day degrees from the 15th of November. And then what you can do is convert these day degrees into dates, and so hopefully there might be some further development happening in the model, but you can accumulate day degrees yourself as well, which might need to be discussed. So yeah, that is a preliminary forecast of the bean seed fly. So just going on to the final conclusions from the PhD. But as Rosemary said, this is being recorded, so you can watch it back if you want to go back and get any details. There we go. So just going back to sort of the classic IPM pyramid, which focuses on preventing damage to begin with, and then working up to the more responsive actions like biological, physical and chemical control. So this PhD project is mainly focused on that bottom level and looking at two methods of cultural control, looking at experiments within, sorry, my phone is just ringing, within, sorry, apologies about that. And then looking at monitoring methodologies, and then looking at a preliminary forecast. But there is so much more to be researched for the bean seed fly, so I'm just going to work my way up the pyramid on other things that need to be done. So we identified in the discussion of the thesis that potentially there could be some work on host plant resistance. However, bean seed flies are generalists, so it will have a go at anything, but this might be something of future research pathways. And then you've got looking maybe at polyculture, so intercropping as another way of preventing damage. As Rosemary said, within that second level of the IPM pyramid, smart traps. So yeah, I'd say from those experiments, it's sort of maybe working out how to get the camera to be looking at the trap when it's got all of these adjustments to it, which were suggested from the findings of the experiments from objective number 2. Looking at objective number 3, I did look at validating the model with some observed counts of bean seed fly, but this needs further development. Then thinking more at that physical level of physically stopping an insect from actually getting to the soil is potentially looking at how do we scale up row covers if they are thought of to be viable economically and at a field scale. And then potentially some research into biocontrol, which is, I think, quite minimal at the moment, And then I won't go into the chemical control because I think this might be discussed in a little while. So thank you very much for listening. Yeah, like I said, I'm very happy to take questions now and also through Twitter or LinkedIn. Yeah, and just a thank you to Rosemary for being an amazing supervisor, Becky as well for being an amazing help at PGRO. Andy and Maz were amazing whilst doing the project. And yeah, everyone else that has helped along the way. Yeah, thank you.
Brilliant. Thank you very much, Becca. That's great. So we've got one question, which is from John Allen. He's asking whether you could clarify horizontal orientation. So is the sticky surface up or down?
Oh yeah, sorry, yeah, that needed to be clarified. The sticky surface is facing the sky, so not, yeah, and it's I could go back to it. It might take a little while with my laptop being a bit slow, but yeah, we found, so previous research by a researcher at Warwick Crop Centre looked at angles of inclination for traps for sort of Delia species, and that was also including cabbage root fly as well. And they found that the horizontal traps that were facing the sky caught more bean seed fly than traps that were at different angles. So we went with that, and we also added the lure to it this time as well.
Thanks, Becca. And just to say that yeah, we've changed because of our results on overwintering biology, we've changed the start date of the day degree forecast, haven't we, effectively, from it was the 1st of January, and now we're going in the middle of November because of what Becca's found out about the life cycle, which is very interesting for us biologists, but maybe not so interesting for everyone else. So I think there's another question. Hang on. Yeah, from Gary. Many thanks. Back to basic biology. Do the adult females lay eggs solely on the volatiles of cultivated soils, or can they also detect volatiles from germinating seeds as well?
Yeah, good question. Yeah, so there have been experiments that have solely identified sort of chemicals that are released from germinating seeds in the soil and sort of emerging seeds. And there's something that is released from those plants at that specific growth stage that attracts the female to lay its eggs on the soil. However, there are volatiles that are released from the soil when it's cultivated, which also attract bean seed fly to lay eggs. But there hasn't been like a combination between both of those things to work out to do any more investigation on that. But yeah, it's that germinating and emerging stage of the crop which really do attract bean seed fly.
Great, thank you. Okay, any more questions? Okay, so Simon, would you like to do a short presentation?
Yeah, I can. I've put a few slides together, so just
Brilliant.
really
Yeah.
shows the pipeline we've got, and let's see if we can find it.
Right, looking good.
Is that okay?
Yeah, fine. Well done.
Good. Okay. So yeah, I've unfortunately I haven't got any new data, but I thought I might as well go through the I guess the pipeline products we have yet to be approved, but which show activity. So I guess the most important thing is to talk about dates. Hopefully you'll be aware, but we've got a lambda cyhalothrin granule called Karate, which first wave approval will be on maize and potatoes. We were hoping that would be at the end of last year. It looks like it's going to be the end of this year. And any veg uses, so leeks and onions, for example, would come as an extension or an emu. So I think really they're in our plans, they're wave 2. So if we don't get the main approval or the first approval till the end of this year, they're going to be 18 months or so away. How, you know, kind of in the way wave 2 works. So it could be late 2026 or for use in 2027, unless there's a way we can do something quicker with an emu. And then Force Evo is a tefluthrin granule, and it will be more speciality crops. So it will be predominantly maize and veg. It's a bit later, but it's in the pipeline. So it's really, those are the two options that we've got that are kind of closest, really. And just a note to say that HCP did some good work this year with the help of growers getting Force for some crops, which is great. That was an emergency approval, and there is an approval in Germany, but the AI loading is much higher than is permitted by the UK authorization, which we have to follow. So I think even though there are regulations about importing treated seed, this would be quite tricky, really, because it exceeds the 13 grams of AI per hectare, which is the kind of the lead approval on sugar beet. So just a couple of slides about the products we have. So Force, so Karate, as I said, is a lambda product, lambda-based granule. Initially, potato approval, and then vegetables, 10 to 15 grams, kilograms per hectare. I'm getting my words terrible today. It will be an info treatment, so it will go through your granule applicator, and it will be primarily for wireworm in potatoes. And we've seen some activity on other pests, so bean seed fly, for example, which is, yeah, I guess we've seen it in development, but it was a surprise to me, really, knowing how the granule works by contact and ingestion. The other granule is Force, which has got the vapor activity, and I thought this would be probably the most effective out of the two, but the lambda granule looks good. The Force granule is much more coarse, and it's got nutrient in it, so it's got a mixture of manganese and zinc and some other nutrients in there, which I think kind of help plant growth a little. Probably contributes towards improving emergence, etc. And again, in-furrow treatment through a granule applicator. So the difference between the two is, as I said, the Force granule is much coarser, and the Karate granule, so the I guess the coarseness of the more dispersed presentation in the soil means that the vapor activity is useful, whereas the Karate granule is much finer, so you get a much more even distribution through the soil profile. So it's kind of 6 and 2 3s when you look at the way the two granules work by their mode of action, but also by their size and distribution through the soil. Just a couple of graphs on data, and I think some of you certainly would have seen this before, but it's just really to point out why I think they're interesting developments going forward. So we look at the graph on the left. The 100% is the taking untreated at 100%. So if you look across to the right-hand graph, for instance, over time, the amount of seedlings falls. So in this situation, it's making it 100%. So you can see effectively with the Force Evo, so with the tefluthrin granule, the population is increasing over time. With the nutrient granule, basically this was just to rule out the kind of, well, or try and measure the effect that including nutrient in with Force had. And you can see it's almost worked out to be like a second check. So it's not had a great effect. And you can see the lambda granule performing very well as well. So as I said, good activity really from a contact and ingestion type activity product. And then the coded on the end here is just similar to the lambda formulation. So it's quite high pressure, so 35% of plant losses, and as you can see, good activity. So if you look at the plant counts, you can see over time they're going down, but with both the tefluorin and the lambda granule much or significant increase in plants. And the second trial showed very similar, to be fair. So again, good level of damage if you look at the untreated, but plant population much higher, although some decline over time. So that's all I was going to say. I don't know if there's any questions, or obviously nothing comes as quick as anybody wants it to, and certainly that seems to be true at the minute. But that's what we have in the pipeline.
Great, many thanks, Simon. That's brilliant. So I think there's a question from Becky. Becky, do you want to ask it?
Yes, yeah, thanks. It was just a very quick one. Just to clarify, peas and beans likely targets in the veg sector for either of those products, for SIBO or Karate.
I think we're aware of the issues in peas and beans, and I would like to say that they would be included in, if we can do work with certainly the Karate in the short term, the lambda granule, and try and get those on priority for development. Yeah.
And the 4-SIBO granule, what's the...
Yeah, I think the 4-SIBO granules was really seen as more of a speciality crop granule, so that had a big scope of veg crops on it. The lambda one is, I think the activity is better than we expected, really. So it's just a matter of, yeah, even if we can do emus or something, if we can find enough crops and enough data to support some emus or something, that would be great. But obviously that's requires resource and requires adequate data.
Thanks, Simon.
Great, thank you. Oh, Gary, do you want to ask your question?
Okay, thanks, Rosemary. Just a longer term thought for Simon. In other countries, Syngenta has now developed an in-furrow treatment using cyanotraniliprole for soil pests. In the US, I think it's got a label now for dipteran and beetle larval pests. Just wondering whether Syngenta might develop this active for soil treatment in Europe.
I can't say no, but I can't say yes either. I think there are, yeah, there's some obvious targets for cyanotraniliprole as a soil or early plant treatment. But yeah, I think if there is that development, it's probably a good, it'll be 2030 plus. I haven't seen anything, but as you say, it's not impossible that it's being looked at because it's in elsewhere in the world.
It's certainly in Africa. It's also controlling virus diseases spread by aphids on maize, for example, which is being used as a seed treatment on maize.
Okay.
So, you know, sugar beet might be another candidate.
Yeah. Okay.
They're claiming 5-6 weeks protection after emergence.
Right. Okay. Well,
so it seems to be quite systemic.
Certainly, we have cyanotraniliprole as a plant treatment, and it will probably, yeah, as a treatment in brassica plants, it probably gives you 4 to 5 weeks aphid reduction.
Yeah. Okay, thanks.
No problem. Thank you.
Thank you. Right. Any more questions for either Simon or Becca before we wind up? Oh, yep. Becky again.
Yeah, sorry.
Yeah.
Just going back to Becca, actually, just very quickly. On the model, the Data Green model, and sort of predicting timing of infestations, and is there, at the moment, it's a thesis, isn't it? So will we be able to sort of develop that into a usable model, do you think, at some point? Does it need further funding, or is it something you can hand over to an organisation like us to do, or would be willing to even, actually?
Sorry, yeah, I think really good question, and hi Becky, by the way. Yeah, I think it can be handed over as it is. Rosemary might be best to answer that question as well. So
Maybe it's warrants
I would be keen for it to be handed over so it's actually useful.
Yes,
maybe
I think
for a discussion perhaps.
yeah, no, I mean it can be available, and can be available. I mean it's a basic data green model, and it can be available to be tried out. And I guess it may need some more testing against well the data we've got on bean seed fly activity at our end, but certainly others are welcome to try.
Thank you.
So yeah,
okay,
yeah. Great.
Come back to.
Yeah, Phil, did you want to ask a question?
Yeah, it was about the same question, to be honest.
Oh, right.
So you just answered it. Thanks.
Yeah. Right, and then there's another question from Gary. So yeah, can Becca tell us if her new job will be in agricultural entomology?
It is in agriculture. It's not specifically in entomology. I'm now the sustainability researcher for Riverford organic growers. So yeah, doing various things with them at the moment, but maybe some entomology might come into play. I'm not sure. But I do love entomology, so yeah.
Brilliant. Right. Okay, any final question? Oops. And yeah, congratulations to you. Sounds fab.
Thanks,
Brilliant.
Rebecca.
Great. Okay, right. So I think we'll wind it up here. So many thanks to Becca and Simon for your contributions. As I say, the recording we'll put on the website and probably the slides as well. And if you have any thoughts afterwards, then yeah, please contact Becca, Simon, and/or me. And thank you for joining us. And good night.
Thank you.